This is a two-tone signal. Yeah, you see it's two-tone
It's in the time domain.
Yeah, in the time domain.
Yeah.
I can always show it in the frequency domain. The signal. It's 250 megasamples per second on this moment.
The clock. The clock is 250.
But it's 250 megasamples also.
Okay.
Per second, and you see here the two the two frequencies.
The two tones, yeah.
Two tones. Yeah. In the frequency domain. So it's a ramp signal in time domain. It is 700 megasamples per second, and it came from
the clock.
From the FPGA to the DAC.
Oh, okay. Can we go faster?
No, if we go faster we get digital faults because of
all this wiring, I
all
see.
This wiring, yeah.
But why all this wiring? Why can't we just simply get this blue cable and get it here on the test board?
There is a design fault in this connector of the test print. And through this fault it's only possible to put 12 signals into the DAC. And
so 12 LSB digital signal data.
12, yes. Yeah. And in this manner it's possible to get 16 LSB data.
So you made kind of a patch, you use this board in the middle to convert just the signals.
Yes,
to reroute the signals.
Yes, and to get more signals to the DAC.
So that's why you're limited in speed.
Yes.
Okay. So if you increase here the sampling rate, you get some kind of digital data, which is quite visible. Can we do this?
Yeah, 800 megahertz maybe. I don't know.
Oh, okay. Yeah. And now we see the digital data.
You can see here all faults.
So along the way in these high speeds, we lose some digital data here in the cables. Okay. For a signal sine wave, what is the maximum speed you can achieve?
590 megasamples per second.
And then to achieve this, you have connected the
board directly.
Oh, okay. So we are seeing now in the frequency domain.
Yeah.
The output of the DAC. Can we see it also in the time domain?
The time domain, yeah. It's 10 megahertz sine wave, and this is a time domain.
So 590 megasample per second for the clock is the maximum speed you can achieve, and you get a clean spectrum. What will happen if we increase further the sampling rate?
I should show it. You get a lot of digital faults, and
okay, these are digital errors.
Yes.
So some of the bits of the data cannot propagate properly and get into the test chip DAC.
Yes.
Yeah. So in brief, you generate the digital data here, and you transfer it to the DAC, and then you measure the DAC. As simple as it is. But why we want to generate the digital data with an FPGA and not like before with a data generator? This is a data generator, digital data generator, this box. So basically the FPGA this small board is meant to substitute this big box, the data generator. This is for your project.
Yeah.
Can you tell us what are the advantages, disadvantages between these two approaches?
Now, the speed of this current data generator on the TU is 650 megasamples per second. The modern data generators can have a speed of some gigasamples per second, but yeah, we have it here on the TU, and this FPGA board can have a speed of 1.2 gigasamples per second. Another disadvantage is the price of this data generator. It's 60,000 euros and very high cost. And we have here an NL550 board from 2,500 euros, so it's much lower than the data generator. The data of the data generator come always from a static memory, so it can't generate data by itself. But here we have FPGA, and he can also send data from memory, but it's also possible to generate the data by itself in
Real time.
Real time, yeah. And we can change the frequency and the amplitude.
So this.
And these things is, I think, not possible with the data generator. Not so user-friendly.
So as for
the
convenience of use, which is easier to use, the FPGA or the data generator?
On this moment, the data generator.
Okay.
The level of a single level is. Can you change with a data generator? But the high level is on this moment 1.35 and the low level 1.5. It's the best levels for measuring the DAC.
This particular DAC,
yes,
the optimal point.
But the FPGA have a standard LVDS value. You can't change it, so it's yeah, you can't change the level.
It's the standard. Yeah.
It's a standard.
So
value.
you cannot fine-tune the analog properties of the digital signals according to the particular DAC. Oh, okay.
Okay, and also it has a lot of cables. Always, you can change it. It's a very huge box, and yeah, an FPGA. It's small, and if the connector was right, the only connection we need is this cable, so it's easy to connect it. So
yeah.